Hi, on today's video I'm going to show you an example of a system that picks up regolith and then transports ice water on the moon. And we model this with something called OPM, Process Methodology, and it's a very cool tool and method. So it's two things. You use the method, that's a way to think about things, but at the same time you also use a tool that allows you to model the objects process like excavating regolith, transporting regolith. But you also model all the things that have to do with is the regolith very hard, or what type of machinery do we have, and I'll even put some simulation results in here. So please enjoy as you see these very brief seconds of moving water, ice on the moon, and yes, it helped us to be the NASA runner-up award. Enjoy the day. So I'll briefly walk you through the objects that we have in here. This is NASA as an entity, and it does need to bring the technology gaps for the human presence on the moon, bringing them from high to low. And these are many technology gaps. In this case, it's a non-optimized water production. Our system in particular is in here with this big box. It's a regolith water extraction system architecture. So the thing, the how are is these things connected? We do have a problem to solve, that we need to excavate large quantities of icy regolith, and for that we need the regolith transporter and the regolith excavator. Overall, as big pieces of things that we need up there, and we are bringing delivery of large quantities of water from low to high. And of course, this is measured by water transported. We can, and this is one of the coolest things, we can go inside and see what are all the steps inside that process. And well, inside how do you have the water extraction regolith in there. And as we go back to SD1, so at this level, one more level, SD, we go back to the high level one. Okay, so really interesting parts. Again, the think about this. I know it has a lot of arrows, but right now, think about this as the build up of the main inputs and outputs. The cool part, an optimized water production end to end. You'll see, you'll like it. We can remove, we can show the in-zoom views. It's like you're diving inside this block, okay? And you'll see, oh, that is so nice. We got a new feature. The platform is always evolving. So you know that in order for this to happen, the optimized end-to-end needs to what? Extract the regolith, transport, and then transport water. And then in here we have all the step-by-steps, the things that are needed to do that. In this case, a regolith transporter. It's a thing. So one of the cool parts in the OPM is that it characterizes objects into objects, processes. Pretty straightforward, correct? Let me show a bit more of the engine. Do I have zooms in here? Okay. Let me go to SD2 because I might have more. Yeah, I've worked more in another model with that. Another part in here that is pretty cool is this. Let me go up to the SD top. Is that we can simulate results, and this is very interesting because in a way it allows you to have this graphical view, okay, of the goal and the process and the entities, but at the same time hit execute. Of course, you need to load the model with stuff, okay? You need to say what's the percentage of water transported, all of the things that you might think, okay? And what's the height of the regolith, what are the speed that the rovers will move. Those things need to go in. But those are, I would say, if you want to simulate something, you need to have some assumptions. So it's a way to test your assumptions with. So it's an analytical model and a graphical model that puts up data. Here I go. So we see that the inputs are coming in, they go to the extraction of regolith, they utilize the transporters, and at the end, we will have whether we can import values from an Excel sheet or we can download all the objects, okay? So that, we need, of course, we need then to select some of these. So analytical, modeling, web platform, what do you want more? And yes, it's fully focused on space. I love it. Enjoy.